Hi, everybody. So this is part two of the portfolio optimization video series that I'm creating with MATLAB, and I'm going to add some stuff to this now. So I changed up the stocks a bit. I'm going to hit run just to show how the screen runs. Oh yeah, let me pin the camera. Okay, so this is let's see. Okay, I think I'm going to add back Tesla. So it's going to be, so yeah, let's see how this looks. So run. Okay, I wish this curve wasn't as, wait, what if I do this? Oh yeah, it's all about the view. Okay, so yeah, so now what I'm gonna do is solve for the max Sharp portfolio. And in order to do that, well, maybe first what I should do is compute the beta. So that'll be, I'll create a function up here. I'll call it function beta equals beta, and it just takes the argument of x. And then what it's gonna do is, so I'm gonna fetch spy equals request of SPY T0 T1. So yeah, I actually need to include T0 and T1 in this. So the next thing I'm gonna do is create a list called SP500 equals um, zeros of the length of spy by 1, and then it'll be for I equals 1 to the length of spy. It'll be, yeah, let me zoom in on this. So I will do SPY of I equals oh no, SP 500 of I equals SPY I of adjusted close. And then this will be SP 500 equals ROR of SP 500. So then I'm going to do display size of SP 500 and then display size of X. So now I'm going to come down here and call beta. So beta of X, T0 and T1. So let me go ahead and run it. Okay, all right, this is weird. It's coming out as, wait, what did okay, it's not supposed to, um, let me go ahead and make an experiment. So I'll do X equals X of, no, X, 1 equals empty list. So let me run this again. All right, this is weird. 1,967. Wait, in the request function. Okay, so I'll get rid of that. Um, Okay, okay, I'm not gonna worry too much about it. So I'm gonna do this. I'll do stocks equals X transpose. So display the size of stocks. Wait, did I even like? Oh, that's why. Okay, I am so glad I caught this error. So I had the wrong input into it. Um, yeah, beta. Okay, so good. So that means, so it's 8 by 246. So what I'm gonna do is come here and do for I equals 1 to the length of stocks, and that, so it'll be cov equals, so the covariance, no, I'll call it covar equals SP 500 by stocks of I transpose. All right, cove. So then it'll be, so I'll come here and do beta, no, just B equals empty list. Um, and then I will come down here and do B equals B, comma, covar of 1, 1, no, 1, 2, divided by covar of 1, 1. So this gives us the beta, and then I'm going to come down here and do beta equals B, and that, so now I will come here and display beta. Okay, load all the stocks. Okay, there's an issue. The number of elements in X and Y must match. Okay, so yeah, come back up here, and I guess it is. I don't have to transpose it. The number of elements in X and Y must match. Okay, so this is what I'm gonna do. I'm gonna comment this line out, comment this out. I'm gonna display size of SP 500, display size of stocks of I, and then break. Okay, so run it. Okay, so it's having an issue. Oh right. I think what I need to do is get rid of stocks. Just do, so it'll be covariance of stocks, freeze the row and then the column. So then I'll come down here and do I have, yep, I have display beta. So let's see what it looks like. Unrecognized variable stocks. Oh, X1. So this will be X. Okay, good thing I caught that error. So now let me run it again. Okay, so what I'm gonna do is display the covariance. Because this should have worked. I don't quite know what happened. Yeah, it's only printing out one beta. Okay, this is what I'm gonna do. I'm just gonna do n. So n is gonna be an input. So I'm gonna come down here and do length of tickers. So now let's run this. Oh, yeah, that solved it. Okay. Um, so what it has to be is this has to be zeros of n by 1, and then it'll be beta of I equals the covariance divided by the variance. So now I'm going to run this again, make sure it prints all out. Okay, perfect. So we got our betas now. Now the next step is to compute the max sharp portfolio. So that'll be, where should I do this? Okay, so function max sharp equals max sharp, and it takes the argument of x, which is the rate of returns. So it'll be mu equals mean of x, covar equals covariance of x, I covar equals the inverse of the covariance matrix. Top is going to equal mu transpose times the inverse I covariance. So I'll display top. So then I will come down here below beta. So I'm just gonna call this beta lowercase beta. We've already computed it. We don't need to do anything else with it. But now I'm gonna do m, so max sharp of ROR. Um, so yeah, run it. Okay, so we have an error. Incorrect dimensions. Okay, so let me go ahead and display the size. Oh wait, no. I don't need to transpose it, I think. I think I do top equals I covar times mu, display top. So let me run this again. Okay, ran into an issue here. I think I know the covariance matrix is just like an n by n. Um, maybe if I do mu trans. Hold on. This is what I'm gonna do. I'm gonna so display size of I covar, display size of mu. So yeah, let me go ahead and run this now. Okay, 8 by 8, 1 by 8. Okay, so this is why it's not working. Okay, so it actually would be top equals mu times I covar. 1 equals 1s to the length of mu by 1, and then bottom equals, let me display 1. So this should run. Okay, so I think bottom should equal 1 transpose times top. So display bottom. Yeah, I'm getting the data from financial model. I think I included it in the previous video. Number of rows. Okay, I need a Okay, let me take this out. So display size of 1, display size of top. Let me run this again. 8 by 1 and 1 by 8. Okay, so bottom is gonna be, wait, okay, so 1 is an 8 by 1. Top is 1 by 8. Um, so it would be top times 1? Yeah, yeah. So bot equals top times 1. So display bottom. So yeah, this should be a single number. Um, yep. Okay. So then it's just gonna be weight, no, weight equals um top divided by bottom, and then risk is gonna be the square root of W transpose times the covariance matrix times W, and then the return is gonna be weights multiplied by, rather mu multiplied by weight, I think. So display risk, display return, not ret run. Okay, so let's run this hopefully for the last time. Um, okay, yeah, narrow that shit. Oh right, it's weights multiplied by covariance times weights transpose. Um, actually, you know what? No, 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 no. I shouldn't even do that. I should do display W, display so covariance matrix, or no, size of covariance matrix, um, size of W, and display size of mu. Yeah, this is so tricky for me. Like, I'm very new to this, but I'm trying to like master it. I've said it before, but like, I like MATLAB a lot. Like, I want to get really good at it. Okay, so I don't need that graph right now, but so weights is 1 by 8, covariance is 8 by 8, and mu is 1 by 8. Okay. Let me just keep these here just for reference. I'm gonna comment them out. Um, so risk is going to equal, so risk is going to equal the square root of, let me get rid of that. So weights are 1 by 8. So that'll be weight multiplied by covariance multiplied by weight transpose. And gain is going to be, so mu is 1 by 8, weights are 1 by 8. Um, so it's going to be W times mu transpose. Okay, and then so I'm gonna return three things from here. I'm gonna wait, or unless I just need the weights. So risk and gain. So I'll call this MX MY. So mx equals risk, my equals gain. Um, and oh yeah, for the I should also include weights for the max sharp beta computation. Yeah, so that'll be weights equals W. Okay, so now I come down here to max sharp and I will do mx, my, mw equals max sharp. So I'm going to come down here and do scatter of mx, my. I'm going to make it green. Um, I should probably also wait. Yeah, let me just go ahead and plot the max sharp ratio. Wow. Okay, I deserve that. Okay. Yeah, that had to happen. That was like the perfect moment for that to happen. I forgot I was supposed to do covar, not cove. So then run it again. And we got it. So, this is our max sharp portfolio. So now let's compute the beta. So that'll be so I got beta, um, and this will be an annotation. So I will do where'd it go? Okay, beta and max sharp. So this will be portfolio beta equals MW times beta. And let's add some text to this. So it'll be text of MX, MY, and then in the list num2 string portfolio beta. Oh my God. I hate this laptop. I love it, but I hate it. Like, I keep putting my hand on the fucking trackpad and it ticks me off. But okay, portfolio beta. Okay, so let me also um I'm just gonna add all this myself. So compute that. I also add the semicolon so it doesn't fuck up more. Okay, so load all these stocks. Okay, so our max sharp portfolio's beta is 0.91362, which is slightly under the market, so it's actually not that risky. I guess it's not weighting it towards Tesla. So maybe what I should do is just come here and write portfolio beta plus the num2 string. And I'm gonna make it to 4. Yeah, I'm gonna make it to 4. So now let's just do the capital allocation line. So that'll be so it'll okay, yeah, I should do it right here. Oh my God. Oh my God. All right. So fetch data max sharp. So function cxcy equals capital allocation line, and it just takes the argument of um, mx, my, end. So w will equal 0, 1, and 2, and then it'll be for I equals 1, 2, 3, end. Um, okay, so this will be x equals x by weight of I times, oh, right, I need to include y. So weight of I times mx, and then y equals y, weight of I times my, and then I'm going to do cx equals x, cy equals y. So I will come here and do the capital allocation line. So that'll be, I'll do cx, cy equals capital allocation line of mx, my. And then I'm going to go ahead and plot it. So that'll be plot of cx, cy, and I'm going to just color this black. So now let's see what the final piece looks like. And we got it. So let me zoom in on this. So our max Sharp portfolio beta is 0.9136, and we can see that a lot of the stocks in our portfolio are concentrated here, apart from Qualcomm and Tesla. But yeah, overall, I think we did everything we needed to in this video. So yeah, I thank you all for watching this video. I'm gonna keep coming out with more and more cool content related to quant finance, so stay tuned and peace out.